Good morning, students. This is Shiraz Patel and welcome to Maths Chef YouTube channel. Okay, already you know we're discussing about the real numbers from the class 10 CBSE books. This one, okay. So yesterday I solved some questions. Find out the LCM HCF by the prime factorization method. And one I made mistake is while I dividing the 3 to 760, 3 to 760, okay, I wrote the prime factorization except 13, right? Okay, 2 cube, right? 2 cube, 3 cube, na? This is like that, 2 into 2 into 2 into 3 into 3, right? Into 5 into 7, accepted. This one accepted, okay? Even though I wrote it last time, but in the beginning also, I skipped this one. 13 also prime number, na? Okay, and I taken this one. Na? So this is the complete product. Okay, whenever I am reading the first time, I wrote here like that. Na? I make this one and this one. I write this one as only. I skipped the 13 for all 2 steps. So please consider it. Have to multiply 13 also. Okay, and today is the revisiting the rational number. Next concept. Okay, questions are very easy. Exercise 1.2. Exercise 1.2 or questions are very easy. Okay, exercise 1.2. Okay, solve yourself. And then at the end of the class, end of the chapter, again I will conclude. Okay, I will give you some again a revision and plus and some. I will see the questions which are difficult and I will solve it. Okay. Okay, sir. Today is the revisiting the rational number. Revisiting the rational numbers. Revisiting. Okay, revisiting means already know about something else, about rational number. Revisiting the rational number. Irrational number, no? Not rational. Revisiting the irrational numbers. The concept is revisiting the irrational numbers. There is no irrational numbers, right? Irrational numbers. Okay, we have the natural number, real number, natural number, whole number, integers, and rational number. Rational numbers we have some concepts. Okay, rational numbers we have rational. So here we have we might know. So it is in the P by Q form, and okay, Q is not equal to 0, and P and Q have the common factor 1, except P and Q common factor 1. So 2 and 3 as the rational number. Okay, 4 and 3, 4 and 6, right? 4 and 6. This you can write 2 into 2 by 3 into 2. 2 is common. This is called the factor of 2 and 3. The factor is not a called a rational number, but still this is the standard form. This is the factor form, whatever it may be. Okay, if you want to find the rational number from this one, you have to write this one. Okay, because 2 and 3 should be have only one as a common factor. That is the beauty of the rational number, main definition. Okay, here we get the terminating, non-terminating, repeating. Okay, terminating, non-terminating. Terminating we have again 2 parts. Okay. Actually this is the next syllabus. Terminating decimals, right? Terminating like 2 by 5, okay, 1 by 10. Terminating decimals, and here non-terminating, right? 1 by 7. Okay, but multiples of whatever. Okay, then here we have different recurring and non-recurring, repeating or non-repeating, recurring and non-recurring. Recurring means repeating and non-repeating, non-recurring. This portion is called the rational numbers, the type of non-terminating and non-recurring. You cannot write in the form of P by Q. So this is called irrational number. Okay. Just know the theory only. Okay. Means also irrational number. Okay. Irrational number. Okay. The T also we can write. They given. This is not in the form of P by Q. Cannot be written in the form of P by Q. That's also true. This is also non-okay, sir. If terminating, you can write this form. If repeating also, we can write in this form. But non-repeating, non-recurring, you cannot write in this form, no? So, example, root 2, root 3, root 7, okay, cube root of 7, cube root of 11, okay. All values under the root 3, under root 2, root 3, except the perfect square and perfect cube, corresponding values. For the perfect root cube, cube root, and that should not be under the perfect cube, and for square should not be under the perfect square. Okay, these are and again pi have 3.142. Okay, non-repeating. See here, pi is a approximate value. 22/7 is approximate. Approximate value means it's the rational number. Terminates somewhere else, recurs and terminates. Not terminates, recurs somewhere else. Okay. If we do the multiplication division, we came to know what the rational number is. Irrational number is okay. Non-repeating, non-terminating, non-repeating, non-recurring. Very important. And cannot be write in the form of P by Q. That is also true. And okay, it has the infinite decimals, non-repeating, non-terminating decimals, decimal expansion. Okay, that's the truth. Okay, there's the theorem here. One theorem is there. Again, what the irrational number is? See, there are the rational numbers have the terminating decimals and non-terminating decimals. For terminating decimal, non-terminating has a recurring like that, na? So you can write 7, okay, 0.7 bar means 0.7777 up to infinite. So this can write 7 by 9, 7 by 9, I think so. Okay, for the method here, if x is equal to 0.7, so x is equal to 0.7 and 10x is equal to okay 7.7. This is 10x is equal to 7 plus x, right? The whole method finding the value. So this becomes 9x is equal to 7. Right here 7 by 9, right? X 10x minus 9 comes left side. So x is equal to 7 by 9, right? 70, yes, 9 by 7. That is the non-terminating. Okay, sir. This is the non-terminating. 7 by 9 is non-terminating and recurring. Recurring in terms of recurring the decimal 7 and 7, 7, 7 at infinite times. So this number is irrational number is non-terminating and non-recurring, non-repeating. Okay, like that root 2. Okay, root 2, root 3, okay, 0.10, 100, 100, 100, 140, 150, 160, right? Unlimited, any you can write. That number should not be repeated. Decimal expansion should not be repeated. Okay, sir. One theorem is there to prove whether number is irrational or rational number. Okay, we will take it by the example. Proof is not in the perspective of examination, but theorem is in perspective of examination. Okay. So theorem is okay. Let okay. A is any integer. You cannot write the whole things here. A is any positive integer. Okay. And P is the prime number. If P divides. Okay, sir. If if P divides A square, then P divides A, where P is prime number, prime, and A is the positive integer. The condition is if. Then the condition if, okay, if P divides A square, then P divides A. Let's consider, sir. If I get 10, I take 36. I'm taking 36. Okay. Out of 36 is 6 square. 6 square. You can write as 2 into 3 whole square. This you can write 4 into 9 also. Okay. We need prime numbers, na? Okay. 2 into 3 into 2 into 3. Right? 3, 6, okay. There are only 2 prime numbers. 2 and 3 here, prime numbers. Okay. See, this you can write this one as 6 square by 3. Can I write as 2 into 3. 1 3 comes this side. This is called 3 divides 6 square. Right, sir? 3 divides 6 square. Okay. If it is true, we can divide 6 by 3 also. Obviously. Right? Because 6 square we can write 6 into 6 by 3. 3 ones are 3 twos are. This is the theorem. If a P divides, if a 3 divides 6 square, okay, you can write here. Okay, example. If 3 divides 6 square, then 3 divides 6. Means now here, this should be prime number. Very important. Okay, divisor should be prime number. See, A by B means, should write it. In finding the GCD in class 11, you know, is here B divides A. Should write this one as B divides A. A is Navin, here our study is A is divided by B. A is divided by B. That passive is na. That passive. Active is B divides A. B divides A. 3 divides 6 square. 3 divides 6. P divides A square. P divides A. The theorem. Proof is not necessary. Okay. They clearly mention. And we should waste the time. There are 2 concepts only. Let's see. Prove that root 2 is an irrational number. Prove that root 2 is an irrational number. How to prove the root 2 is an irrational number? By contradiction theorem, right? Prove that PT root 2 is irrational. Irrational. Okay. Big first, okay. ಕನ್ನಡ ಮೀಡಿಯಂ ಅಲ್ಲ, ಕನ್ನಡ ಮೀಡಿಯಂ ಮರ್ತೋದೆ. ಓಕೆ, ರೂಢಿ ಆಗಿದೆಯಲ್ಲ ಇಂಗ್ಲೀಷ್ ಮಾತಾಡಿ. ಓಕೆ, ನಾವು ರೂಟ್ 2 ನ ಇದಕ್ಕೆ ಯಾವ ಕರೀತಾರೆ? ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳನ್ನು ಕರೀತಾರ, ರೈಟ್? ಮೇ ಬಿ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳಲ್ಲ, ಇರ್ರಾಷನಲ್ ನಂಬರ್ ಏನೋ ಕರಿಬಹುದು. ಓಕೆ, ಲೆಟ್ ಬಿ ಅಪ್ರೂವ್ ದಟ್. ಓಕೆ, ಇದು ನಾವು ಏನಂತ ಇರ್ರಾಷನಲ್ ನಂಬರ್ ಅಂತ ತೋರಿಸಿ, ಇರ್ರಾಷನಲ್ ನಂಬರ್ ಅಂತಂದು ತೋರಿಸ್ತಾ ಇದೆ. ಓಕೆ, ಯಾವ ತರ? ಫಸ್ಟ್ ಗೆ ವಿಲ್ ಸಿ ದಿ root to consider. Okay, let's assume solution. Proof is, let assume, okay, root 2 is a rational number such that C in inside they given R by S. R by S is a factor of, okay, sir, the factor of, okay, factor like that. Means it has the common factor 2 and 2 like that. Okay, I told you na, 2 by 3 is the standard form, 4 by 6 is the factor form. This is the like that. Again they consider if that rational numerator does not have the factor except 1. Okay, if A and B have the have the factors 1 only, then root 2 becomes a by b. Okay, a and b has the co-prime to each other, means 1 co-prime. I am writing as co-prime. Co-prime means a and b have the factors only 1. 2 and 3 are co-prime 1. 3 and 5 are co-prime 1. 7 and 8, 11 are co-prime, means they have the only 1 as a common factor, right? So 6 and 4 and 6 are not co-prime, because this is 4 you can write 2 into 2, 6 you can write 2 into 3. So this is the common factor. So 2 is the common factor for the 4 and 2, that's why it is not a co-prime, not a prime number, but I am telling, okay. Let's consider. In book they given R by S may be a number, but still by dividing the rational number, by taking the standard form, this becomes A by B, right? Becomes A by B. Here A and B are the co-prime to each other. A and B are co-prime to each other, okay? So this is only assume only, very careful. Root 2 is the irrational number. Then A becomes, okay, A becomes B into root 2, okay? This implies A square is equal to, okay, A square is equal to 2B by the theorem, above theorem. If P divides A square, then P divides A also. By theorem, by the theorem, if P divides A square, implies that P divides A. So you can write, okay. Therefore, here A is equal to A, if you can write, if A square is equal to 2B, implies that 2 divides A. Okay, you can write now A square by 2, you can write and write it directly. So you can also, if 2 divides A square, you can write also, okay. Then 2 divides A. If 2 divides A, then A can rise at 2 into C. Multiples of A, not only B, you can write any number. Na? If 2 divides A, you can write any random number, C. Okay. Then squaring on the both sides. Squaring on the both sides, which is equal to 4C. What the value of B, A square is 2B. 2B is equal to 4C. Again, B is equal to 2C. Again, can write this one as B by 2 into C. Again, 2 divides B. Okay, 2 divides B. Therefore, A and B have the common factor 2. Therefore, A and B have common factor 2, which is contradiction to our assumption, because but A and B is equal to 1, co-prime to each other, we assume that A and B are co-prime to each other, but we got it 2 is the factor of both A and B. 2 is the 2 divides A and 2 divides B means 2 is the factor of A and B. So here we can write A is equal to 2 into C and B is equal to 2 into something else. So this is the value. This cannot be true, because if it is true, because you taken precedence, A is equal to A and B are the prime numbers, co-prime numbers. We have only one factor, it is a rational number, but this has the factor is 2. Therefore, our assumption is wrong. If you got the only one factor, then your assumption will be correct. But you are not getting the factor 1. Only one that we are not getting the common factor 1, therefore getting the common factor 2, which is completely wrong to our assumption. Therefore, root 2 is a irrational number. Root 2 is not a rational number. Okay. First tell. Okay. Therefore, we can tell here. Conclusion. Therefore, root 2 is not a rational number. First write this one. A rational number. Okay. Therefore, implies that, or you can write implies that root 2 is, so if it is not rational number, it must be irrational number, because irrational number can be written in the form of p by q, right? Is that irrational? Irrational. Okay. Another same example is for the root 3, right? Can do it also. Another one is there, very interesting example. Compared to ICIC, they are given easy explanations. Prove that, okay, or prove that 5 minus root 3, prove that 5 minus root 3 prove that 5 minus root 3 is irrational. Irrational, right? Prove that 5 minus root 3 is irrational. So in ICSE they given some extra things. Okay, they taken something else and divide and multiplication, that gives something else. Okay, but method is same, right? The answer, the theory, the principle is same. Okay, let's take again. Let's assume proof. Let's assume. Okay, 5 minus root 3 is a rational number. So therefore implies that 5 minus root 3 can be written in form of a by b. So very important, a by b is equal to 1 means co-prime. Rational form, standard form is have the only one as a common factor in the rational number. If you are writing multiples of that common factor, we call a factor of the rational number. They are called factors, right? Important. So here just little arrangement only. Change the arrangements. Okay. 5 minus a by b is equal to root 3. This is enough stuff here. So you can also take given the, let it be. Okay. What is the formula? What is the addition here? In rational numbers, there are fundamental arithmetic operations. Addition, subtraction, multiplication, and division are still gives the rational numbers. Okay, because they are proved. So here, subtraction of the rational number yields. Okay, write this one. Subtraction in rational number or of rational numbers. In rational numbers yields rational numbers again. Yields means gives results. Yields a rational number again. Already we have again. Okay. Therefore 5 minus a by b is a rational number. But root 3 is a irrational. We know that root is the sum value, two values, addition of the rational, addition of subtraction irrational numbers. Okay, so we can take this, but root 3 is the irrational number. Already proved also, but it's true also. Therefore, Root 3 is a rational number. Therefore, 5 minus a by b is not a rational number. Not a rational number. Therefore, this implies that, okay, 5 minus root 3. So, this not rational number means both are equal. No? 5 minus root 3 is the irrational number. Okay, but okay, here this is the important thing here. Our assumption is wrong. Okay, rational number, but our assumption is wrong. Na? We have to write this one rational number. But okay, therefore here we should mention our assumption is wrong. It's contradictory. Assumption is wrong or contradictory. Right? This is the only thing. Therefore, 5 minus a b is not a rational number. 5 minus root 3 is the irrational number. Directly one thing. Okay. Here also, sir. Here also we can write subtraction in rational number. It's a rational number again. But 5 minus a by is equal to root 3, where root 3 is the irrational number. Therefore, sum 5 minus root 3 is a irrational number. You can write that also. That's enough. Okay? This is enough. Right? Next step is, problem is, okay, let's see. So, problems are over here. So, exercise is there. Exercise do yourself. Revisiting the rational numbers and their decimal expansion. Theorem is there. We will complete that theorem. Within a single example, I am giving all the numbers. Okay. Fourth one is, the heading is rational numbers and their decimal expansion. Okay, rational numbers and their decimal expansion. Last concept. Rational numbers and their decimal expansion. Rational numbers and their decimal expansion. Decimal expansion. Rational numbers and decimal expansion. Okay. They given the examples. Let's take their examples. Take the examples. Okay. 3.75, 1.0, 0.85, 2, 3. Right. Here only limit there only, very limited. Okay, let's take some examples. 0.375, 0.14, 0.375, 0.375, and 0.104. Right? 375. Right? Just see, look at here. This can write as 375 by 1000, right? By taking x as equal to something else, whatever it may be. It is the terminating decimal. Terminating decimal, multiplying you can take also value. So this can write as 375 by 10 into the power 3, 10 cube. You know, this can write as this by 375 by 2 into 5 to the power cube. Yes, this can write as 375 by 2 cube into 5 cube. Right? Similarly for this one, 104 bar 1000. So this can write as 1000 divided as 104 by 2 to the power 3 into 5 to the power 3. Okay, this is important. Okay, here 2 and 5 and 2 and 5, 3, 5 to the power 3. Okay, next is okay. This is the this we can write. What is 125 into 3? We can write this 125 into 3. This 2 cube into 5 cube. This is 5 cube into 3 by 2 cube into 5 cube. This can write as 3 by 2 cube. This is 3 by 8. Yes. 3 by 8 expansion is 0.375. 3 by 8 expansion is 0.25. Our motto is here only this 2 to the power 3. See, 5 3 get cancelled, and we get 3 by root 2 cube. We got the 3 by 8. Similarly, we can do it for anything else here. 104. What they given here? For 104, 13 into 2 cube. Okay, 13 into 8. This is 13 into 8 by 2 cube into 5 cube. 13 into 2 cube by, right, 2 cube into 5 to the power cube. This is 13 by 125. Okay, this is the value of this one, decimal. This is the rational number. This is the decimal expansion, right? 13 by 5 cube. Listen, very important again. I will explain here. Okay, by this division method, multiplying the 1000 divided by 1000, I have taken this one and I got this form. By simplifying this one, I got this form. This is the decimal expansion. This is the rational number. So 3 by 8 is equal to, finally, 3 by 8 is equal to 3.375. You can do by calculator also, you can do by the methods also. Okay, but this one, okay, thing is, okay, 3 by 2 cube can I write? This I am dividing by multiply by 5 cube on both side, 5 cube on both side. Okay, this one becomes 3 into 125 by 2 into 5 into 3, because this becomes 375 by 1000, 10 cube. I am writing 10 cube. This one 375 by 1000, 3 by 8. See, if you got 1000, immediately you can write in the form of decimals. Point. Just leave the digits right side. Number of zeros. Just push the digits right side. Point. Right side the point. Okay. This is the method. Okay. If we write, see, the thing is here. If we can write the denominator of any rational number. Okay. Things only. If we can write a denominator in the form of 2 to the power m to the 2 to the 5 to the power n. Okay, any rational number p by 2 to the power m 5 to the power n, right? P by q is equal to such that then p by q is a terminating decimals. Is it terminating decimals? Is the terminating decimal or terminating decimal expansion. Only that's the theorem. Right? Okay, then. This is the thing here only. If you write in the form of any fraction, okay, this is also very important for the computer exam field. 2 into 5, this multiplication. M and N are the positive integers. This is the very important. if any problem has the 2 into 5s, they will get zeros, 1 0. Be careful. Any product has multiples of 2 and 5, 2 and 5, 1 2 1 5, pair of 2 and 5, then definitely it has 1 zeros. Be careful, right? Then this is the theorem. Based on this one, we have the investor. Any expansion or any decimals we can write in the form of, okay, right, 3 by 4 we can write 3 by 4 we can write 3 by 5 square by, okay, 2 square into 5 square, right? This is 5 square means 25, 25 into 3, 75 by 5 to 10, 100. Okay. Just check it, okay. Just check it. 3 by 4, 4 is equal to 4 into 3, okay, 0 point. This becomes 30. 4 7s are 28. Again 2 is the answer, okay. 75 by 4 is the 0 0 answer is the third, okay. This is equal to 0.75. Answer is 75. If it got this one, 75. What is that? Okay. Very important. This one. Or we can write as 3 by 4 is equal to 75 by 100. Because 3 by 4 is the standard form, 70 by 100 is the factor form. 3 by 7 is the 3 by 4 is the factor form. Okay, 75 by 100 is the which one? Factor form. So here we can write the decimals easily. Just put the points. This is right side of the point, 0 point something else. 20 0.75, 30 0.750. If the 10, write the punch and send the 5 that side, 7.5. That's the method. Okay. We'll see theorems. Theorems, I think so, not necessary. But still, I will write theorem. This is the main concept. All three theorems. Okay. If you cannot write in the form, okay. If you cannot write in the any form, okay. Means 3 by 7. 3 by 7. You cannot write in the form of 3 by 5 into 5 into. Cannot write in the form of 2 into 5. Therefore, this as maybe non-recurring, non-terminating decimal expansion. Any denominator, it could not be possible to write in the form of 2 to the power m into 5 to the power n, then that rational number does not have terminating decimals, non-terminating. Maybe recurring or not recurring is secondary, but only motto is non-terminating, that's all. Okay, let's see the theorem 1, theorem 2, theorem 3 and exercise. Exercise. Okay. Okay. Theorem 1.5, theorem 1.6. Just I will dictate and explain. I've done the things already done. Okay. First theorem is, okay, theorem 1.5. Okay. Let x be a rational number whose decimal expansion terminates. Okay. Let x be a rational number. Let x be a rational number. Whose decimal expansion terminates terminates, then x can be expressed in the form of p by q. Then x can be expressed in the form of p by q, where p and q are the co-prime. Very important, where p and q are co-prime. Co-prime means have only one common factor, 2 by 3, 2 by 5, 7 by 5, 7, 11, okay, 19, 11, 19, like that. So should have only one that should be number the prime and should be co-prime. Okay. And the prime factorization of the q is the form of and the prime factorization of q in the form 2 to the power n, 2 to the power n, 5 to the power m. Only q only, na? Very important. Okay. Where m and r non-negative integers. Okay. Where m and r non-negative integers. Theorem 1. Like that, na? I told you. If 0.5 can be expressed in the form of 5 by 10, where you can write 5 by 10 as 2 to the power into 5, right? This becomes 1 by 2, right? This is the form, okay? This is the decimal expansion. First question is, let x, this is the x, let x be a rational number whose decimal expansion terminates. Only one have 5. Then x can be expressed in the form of p by q. Then x can be expressed in the form of p by q such that p and q are the co-primes. Here 1 by 2 are co-primes, and the prime factorization of q is 2 into 5. 2 into 5, right? In the form of 2 to the power 5 and higher, 2n is equal to 1 and m is equal to also 1. M are the positive integers, right? This can be done. This is the x, this is the theorem result. This is the in between. How we do means you are dividing the 5 and 5 both sides. Okay? Means if any number divides by 2 or divides by 5, that is completely terminating. Simple things. Any number divides by 2 or 5 and 2 and 5, that is terminates. Any number. Okay? First theorem is over. Second theorem is let x be p by q form, the reverse almost, okay? Reverse. Let theorem 1.6. See, theorems usually will not ask the questions. Real means by getting the terms with familiar is very important. What is the co-prime? What is the decimal expansion? What is the prime factorization? Okay, to get now these terms, the once or twice. If you ask the hobby of asking the questions, you can write, memorize. But writing theorem as in the books gives the good marks and a good habit also, as it is. So in our language, writing this one, its meaning differs. Okay. So try to follow the theorem as in the book, because they given theorem is bold letter with founted letter. That means they given some priority. Okay. Let x be x equal to p by q. Let x is equal to p by q be a rational number. Be a rational number such that the prime factorization factorization. Prime factorization of q is the form of 2 to the power n 5 to the power m, where n and m are positive integers, then x has a decimal expansion which terminates decimal expansion which terminates right. Okay, solution means, okay, let x be a p by q form. Okay, let x is equal to 2 by 5 can I take, or then any values, and okay, 3 by 20 you can take 7 by 20 also, you can take 7 by 20 or 7 by 20 rational number such that prime fraction of q, p by q be a rational number such that the prime fraction of q is there form of 2 to the power 5 and 5 to the power m, where m and are the positive integers. Then next has a decimal expansion which terminates. Okay, so here 2 by 5 can write as, okay, 2 by 5 into 2 can write, right? This is we can, because now 2 can we can multiply it divide with. This becomes 4 by 20, 4 by 10. So this is equal to 0.4. Yes, 2 by 5 is equal to 0.4. We'll get. Similarly for 7 by 20, we have 7 by 4 into 5, right? 7 into again 7 by, okay, 2 into square into 5. This can be right. Yes, this 7 into 5 by 2 into 5 to the power 2. Can I write? This becomes 35 by 100. This becomes 0.35. Very important. Okay. When denominator we can write in the form of 2 to the power n and 2 to the power m. Then, okay, then this is, okay. Here, see, n is equal to 2, n is equal to 1, n is equal to 2, m is equal to 1. What I done here, I multiply the 5 on both sides to get the equal, this one equal. But this in the form of again, the current question 2 to the power and 5 to the power, maybe any form, okay, maybe any form. So here we can rearrange the things. Such that we get the easiest answer. This becomes, we can do it also. 7 by 20. Okay, 7 by 20. Okay, 20 into 7 point. This becomes 70. Okay, 3. This becomes 60. Right. 10 becomes 100. And 20 into 5, 100. This is 0, 0, 0. 0.75. Right. 0.35. The easiest way to the expansion. In exam, if they ask question, write the 5 by 50, 5 by 60, right, whatever it may be, 5 by 60, something else. If they this denominator getting the multiples of 2 or 5, only single answer. 2, 5 form, then take the 2 into 5 same form, multiply, divide. Okay. If 2 is less, just multiply the equal to bring to the same power of the 5 by multiplying the 2. If the 5 is less, multiply the 5, bring the denominator 5 to the power m to the is equal to the power n, like that. Listen, here 2 have the power 2, 5 the power 1. So what I done here is multiply the 5 to get the 2 to the power 2, 5 to the power 2, same power, because 1 2 1 5 gives the 1 0. Similarly 5 and 2, 1 2 1 5 multiplying gives 1 0. 2 5 2 0 gives the 2 5 2 2 gives the 2 zeros. That's why it 2 zeros, 35. 0.35. This is the second theorem. Okay, next theorem is last theorem. One by 7 they taken. Let's read theorem first. Okay. Let x is equal to p by q. Let theorem 1.7, right? Let x is equal to p by q, where p and q are the co-primes. I am writing this one as is equal to 1. Co-primes, you can write also co-primes, right? Co-primes. Be a rational number. Be a rational number. Rational number. Such that the prime factors of the q is not in the form of 2 to the power n, 5 to the power m. Such that the prime factorization of q is not the form of 2 to the power n, 5 to the power m, where n and m, okay, m and n belongs to z plus. I am writing positive integers. Z plus means positive integers. Okay, non-negative is positive. Then x as a decimal expansion. Okay, decimal expansion which is non-terminating. This is important. What is very important? Climax. Non-terminating and non-repeating. Non-terminating, repeating or recurring. This is the term very important here. The whole theorem. This is the term. Okay, the term is very important here. Non-repeating, recurring. Non-terminating, repeating. Non-terminating, repeating. Like that. Okay. Non-terminating and repeating. 0.47 bar. 0.7. Okay. Like that. No? Or 0.7 is 7 by 9. Like that. So you can write in the form of reciprocal, write in the form of rational number, but it's a non-terminating and repeating. Non-terminating, repeating. They given 1 by 7 also. I will take the easiest one. One by 7 I will take here. So any number, okay, not only 1 by 7, any number 1 by 7, 2 by 7, 5 by, okay, 5 by 17 and 6 by, whatever it may be, 9, 6 by 9, can write 2 by 3, right? 2 by 3. Take simple example. So 2 by 3, this is, so 3 into 2, okay, point, this becomes 0, 6 the 18, again 2, 0, 6 the 18, again 2, 0, 6 the 18, okay. 3 is not in form of 2 to the power n, 5 to the power m, so this becomes 2 by 3 becomes 0.6 bar. Bar means repetition occurs, infinite time repetitions. Okay, let's take the 1 by 7. Okay, they given book an example. 1 by 7 is okay. Is clear? Right. This is 1 by 7. This implies that 7 I am taking this one as and 1. Okay, 0 point, this becomes 10 and this becomes 1, 7, remaining is 3, 0, 4, 28, 2, 0, 2, 14, 6, 0, 7 and 8 are 8, 56, 4, 0, 5, 35, 5, 0, 1, 49, 1, Caesar. Again you got the one now? Here repetition starts. Okay, repetition starts. Again it is like that 1, 4, 2, 8, 5, 1 like that. Again it gives 1, 4, 2, 8, 5, 1 continues infinite. So this I am writing as 1 by 7 is equal to 0.142851, right, as a bar, whole bar. Every number this range repeats, this whole range repeats. So this is the beauty. If the x is the p by q form, where p and q are the co-primes, be a rational number such that prime factorization of the q is not the form of 2 to the power n and 5 to the power m. M and are non-negative integers of 0 into positive integers. Then x has a decimal expansion which is non-terminating, non-terminating, repeating, non-terminating, infinite and repeating 14285, 14285, 14285, unlimited, infinite times. That is the theorem. Repeating means recurring. Okay. So this is the end of the class. I think so. I have done the 3 concepts. Next is the exercise part here. Okay. Exercise part. I will solve the questions together. I will solve the taking the R.D. Sharma. This is the best for this CBSE for. R.S. Agarwal is best for the ICSE material, but many students using R.S. Agarwal also. R.D. Sharma take the question from the R.D. Sharma and these questions. I will solve the only difficult question from this exercise part and some important question from the R.D. Sharma. Okay, let's see. Okay, beginning with conclusion, I will give one again more revision in terms of rational numbers. Because now to define the rational and irrational number, basic understanding. What we see in rational number, okay, rational numbers, we saw, okay, we saw 2 types. One is terminating and non-terminating. Terminating, this is the decimal, sir. I am writing terminating decimal expansion. I am not writing here decimal expansion. I am not writing here. Rational will have the 2 parts: terminating decimal expansion and non-terminating decimal expansion. Terminating decimal expansion has, okay, p by q form, okay, where q is in the form of 2 to the power m or n, okay, n, and okay, into, this should be into 5 to the power n here. Terminating, okay. Here you have the 2 parts again. Repeating or recurring, RECU double RNG, not double C, RNG. Non-recurring, okay, non-recurring, okay, non-recurring. If it is in the form of P by Q, okay, P and Q have co-prime equal to 1 and Q is not in the form of 2 to the power n, 5 to the power n, right. Q is not in the form of 2 to the power n, 5 to the power m, right. This is equal to, okay. If it is not, if the rational number is non-terminating, non-repeating, this portion, okay, this portion gives the irrational number. Irrational rational number. Okay. These two parts are not completely. These parts are rational number. These two parts. Terminating decimal expansion and terminating non-terminating repeating recurring decimal expansion is also rational number. But non-terminating and non-recurring rational number. Okay. Number decimal expansion, not a number. Decimal expansion gives the irrational number. Okay. Non-terminating, non-recurring decimal expansion yields to the irrational number. Different set of numbers. That is irrational numbers. Is completely apart from the rational number. Right? This is the introduction. Next class I will start the questions, exercise questions, solve and question from the RD Sharma will see you. Okay. Thanks for watching. And here this is the online class. YouTube, no one is here to sitting and no one is commenting on me and no one is here to correct me if I done the mistakes. So I extremely apologize for any mistakes, misrepetition, mistakes, misspelling and something else, no? Because I am in the mood of moving the syllabus. Okay, we are only hurry in solving the syllabus. Next questions in that hurry. So yes, teachers make the mistakes and I am absolutely sorry. Summary of make the mistake, no? Please comment in the comment box. So if possible, I will re-edit it. If not possible, I will give the comment regarding the correction. Okay. Thanks for watching and give the valuable feedback. Thank you very much.